Hello everyone, welcome to another video. Hope you guys are doing good. Today we're going to solve another question called delete nodes and return forests. So this is a question based on tree data structure. So let's go through the question. Given the root of a binary tree, each node in the tree has a distinct value. After deleting all nodes with a value in to delete, we are left with a forest, a disjoint union of trees. Return the roots of the trees in the remaining forest. You may return the result in any order. So let's dissect the question. First thing it says is a binary tree. Binary tree in the sense every node have maximum 2 subnodes. Okay, and then it says distinct values in the sense every node will have unique values 2. So and then we will have another array given to us, that is to delete, that will contain values that need to be deleted from the tree. So we now decipher 3 points, and then we will be returning the remaining disjoint union of trees in the sense if we delete a node and it had children, then now the children will become their own nodes and we have to return those. And the last one is like you may return the result in any order. When questions like that says any order, you know that there are multiple solutions, multiple ways to solve this question present, right? Basically because this is a tree question, so I believe if we solve it using DFS, we find the answer in a different order, then we solve it using an iterative method. So those are the hints. But anyway, we have the data we need. Now let's discuss this on the whiteboard. So in example, we are given a tree, right, that starts with root node 1, then goes to 2, 3, 4, 5, 6, and 7, and we have a to delete array list that contains 3 and 5. So as per the question, we're gonna traverse through the node, and whenever we find a node that it matches our to delete list, we have to delete that node. For example, in this particular tree, we have to delete 5 and we have to delete 3. Now, if we delete 3, right, we can mark it like null, then 6 and 7 became their own nodes. So there are 2 steps in this question. One is to delete, and second one is saving our nodes, right? So delete is straightforward. For example, if we want to delete this node, just we have to traverse through this node, and whenever we just find 3, we just have to return null. We mark that node equals to null. If not, we just have to return the node. Simple. If we want to delete while traversing, we just have to compare our node values with the list. If we find that in the list, we just have to mark the node to null. If not, we just have to return the node, right? That will delete the node. But the challenge here is to save the nodes. So what we have to do is, again, we have to create a set, right? So we have to create a set, and the time we are going from top to bottom, we will be saving the nodes. For example, the first node we're going to save is 1. Now we're going to go to 2, we're going to go to 4, the same node. When you go to 4, and at the end it will return null anyway. When node is not there, that is the best case. But again, while traversing, when you find 5, right, we're gonna mark as null anyway. But for this kind of cases, when we find the node is null, we will be marking it null, but now we have to keep track of these two individual nodes. So we're going to push these two nodes to our set, and we have to process these two nodes again with our same DFS. So we have to feed these two nodes to our DFS again, and that will again go through this cycle and keep checking. At the end, right, at the end, our set will have the required answer. Now then, let's try to implement this using our JavaScript. So now the first thing first, we have to create a set. So let set equals to new set, and we're gonna initiate our set with our root value, right? The set dot add and root. After that, we have to write our traverse function, like function trav, and it will take our root. And then base case will be if root is null, right? Not root, then return null. And then we have to write the delete case. What is the delete case? If to delete includes root.val, then we have to mark, let's first assign this value to a temp variable. Let node equals to root, right? So we have to mark node equals to null. If not, return node. So this should take care of our delete case. And then we have to find out if we find it, the node, then we have to delete, and it has left and right, then we have to delete it and save it to the set. So let left equals to root dot left, let right equals to root dot right. Now here, first thing first, if our set has the node, right? If we're marking a node and our set already has it, we have to delete it. So set dot delete node. And once we delete, we have to push the left and right value of that node to our set. So if left, then set dot add left. Same way, if right, set dot add right. So this will take care of the condition that whenever we find a node that is in the to delete list, and once we find it, if the list has left and right, we're going to mark it null and push the left and right child to our set. And then we have to process those two nodes again, right? So here we have to so to process the root is the input argument to our trav function, right? So we have to point our left and right, left and right traversal to those. So it will be like root dot left equals to our trav dot left, then root dot right equals to trav dot right. Yes. So at the end of this trav recursive function, our set should have the required values. So we're going to call this trav root, and then we have to return array from our set. So this should solve our question. So let's try our test cases. I used the same example that we considered on the whiteboard, that has like the root, main root is 1, the head is 1, it has 2 and 3, 2 left and right child, and 2 has left right as 4 5, and 3 has left and right 6 7, and to delete are 3 and 5. So output should be 3 node, one is 1 to 4, and the second one is 6, and third one is 7. So let's run our test case. Okay, it passed. So that's the solution. Thank you for watching.